So, ladies and gentlemen, we have been given a question to determine the eigenvalues of the matrix 3, 4, 2, 1. And we said the eigenvectors show the direction, the eigenvalues show the extent of shrinkage or enlargement of the object that has been transformed by matrix A. And now, we solve this problem by first writing the characteristic equation. And the characteristic equation is matrix A minus lambda into the identity matrix, everything multiplied by vector x, and this is equal to 0. So what you shall get will be a 2 by 2 matrix times a 2 by 1 matrix getting a 2 by 1 matrix. And therefore here we shall be having 0, 0. So lambda we said is the eigenvalue and x is the eigenvector. Now, I is the identity matrix, identity square matrix of the order A. So we said if we have a 2 by 2 matrix, then the identity matrix becomes 1, 0, 0, 1. And we said what we are always going to be looking for is the determinant of the matrix A minus lambda I is equal to 0. Because A minus lambda I is a matrix that we are calling a singular matrix. For it to be singular, then its determinant has to be 0. So we substituted in our values for A and our values for the identity matrix, and we multiply this lambda into this identity matrix and get this matrix lambda 0, 0, lambda. So what we have done is now to go ahead and subtract. So we get 3 minus lambda, we write here. We get 4 minus 0, we write here. We go down and write 2 minus 0, we get to write 2 here. And down here we write 1 minus lambda, which we write down here. So we have to look for the determinant of this matrix. So the determinant of this matrix obviously will be the products of the major diagonal minus the products of the major diagonal minus the products of minor diagonal. So having done that, we are coming up with a quadratic equation which we are solving by factorization method, and we find that lambda is either negative 1 or lambda is 5. And therefore, the eigenvalues of the matrix 3, 4, 2, 1 is negative 1 or 5. Now we are requested to determine the eigenvectors of this same matrix. So 3, 4, 2, 1. We have already obtained the eigenvalues, but now we need the eigenvectors. Now, we are going to use the characteristic equation again, this one minus that, and what we are going to do is to look for the eigenvalues. We are going to get the eigenvectors, of course, using each eigenvalue. So, what we are going to do is that let the eigenvector be x1, x2. And when we do that, for eigenvalue, we are going to do for each eigenvalue. So for eigenvalue, lambda equal to negative 1, A minus, obviously, lambda into I, we multiply by x, this is going to be giving us 0. So this means that I'll have 3, 4, 2, 1 minus 1 into 1, 0, 0, 1. Okay? Everything we are multiplying by x1, x2, and this is equal to 0, 0. That's what we are saying when we are to write this equation in full. So I multiply in here so that I have 3, 4, 2, 1 minus this negative 1 times 1. I will have Okay, let me just say minus 1, 0, because 1 times 1, we have 1. 1 times that, I have that. So, that's what it means. Okay, this was supposed to be a plus. So, I had a 1 minus 1. So, this is going to be a plus instead. So, I'm going to have a plus here. So, times x1, x2 is equal to 0, 0. Now, I add the 2. This is 5. This is 4 plus 4. Then this is 2. This is 2 also. This is how we add matrices. We get 3. You add the corresponding values. 3 and 1, you write here. 4 and 0, you write here. 2 and 0, you write here. 1 and 1, you write here. So, x1, x2, this is equal to 0, 0. So, you can multiply into 4 a row by column. So, I'll have 4, you'll have 4 x1 plus 4 x2, and this is equal to 0. So, I'll have 2 x1 a row by column. So 2 times x2 get 0. So you can see all these equations are almost the same. So what you do, you just pick one equation. So we pick one equation, maybe e.g. equation 2. Then we compare it against each other. So we have 2x1 plus 2x2 is equal to 0. I can further reduce this one by 2, by 2, by 2, so that I have x1 plus x2 equals 0. So this means x1 is equal to negative x2. What does this mean? It means that x1 is always going to be negative 1 times higher. In other words, x1 is always going to be negative 1 times x2. Whatever the value of x1 is, okay? Whatever the value of x2 is, so whatever the value of x2 is, x1 is going to be always negative 1 times greater. So what does that mean? The eigenvalues, if for example I was to substitute it in here, I would have something like this. I would have like 4, 4, and 2, 2. We said we have x1 equal to negative x2. So I have negative x2, then I have x1. I have x2 down here, because I've said x1 is equal to negative x2. So I say this is 0, 0. So meaning I can still say this is 4, 4, 2, 2 into negative 1, 1, then x2. And this is equal to 0, 0. Meaning the least value, if I converted this actually to be, if I was to say the least value of eigenvector, okay, can be either x1 or x2, will always be negative 1 and 1. And therefore, you'll find that your eigenvalue eigenvector for eigenvalue lambda equal to -1 is -1, 1. So let's look for lambda equal to 5. Let's get the eigenvector for this value. So what we do again, we get our A, we subtract alpha, we multiply by I, and obviously we multiply by this x, and this is going to be equal to 0. So we have A minus 5 times I, okay, times x, that is equal to 0. So we know this is 3, 4, 2, 1, minus 5 into 1, 0, 0, 1. So we multiply by x1, x2, and this is equal to 0, 0. So we go forward, we say we have to multiply this together, so we have 3, 4, 2, 1, minus this is 5, 0, 0, 5, because this 5 multiplies throughout, and we have x1, x2, this is equal to 0, 0. So we proceed, so 3 minus 5, we get -2, 4 minus 0, we get 4, 2 minus 0, we get 2, 1 minus 5, we get -4. We are multiplying x1, x2, and this is 0, 0. So we just create two equations, -2 into that, so we'll have -2x1 plus 4x2, this is equal to 0. I can also do the other one and say I have 2x1 minus 4x2, this is equal to 0, and this is equation 2. When you look at the two, they are identical, they are similar. So I can just pick one equation, since they are all the same. So pick one for analysis. So what we do, when we pick one, this is going to be, we can pick one, so equation 1, this is going to be -2x1, so you'll see that from 1, -2x1 plus 4x2 is equal to 0. So what does that mean? I can take 2x1 to the other side so that I have 4x2. I can have 2x1 equal to that, so that I can divide by 2, and I have x1 equals to x2. So if that is the case, that means whatever the value of x2 is, whatever the value of x2 is, x1 is always 2 times greater. So what does that mean? I can come here and say, therefore, x2 is equal to x1 divided by 2. Since from above we got x2, now we can come here and say our x1 is like that. So we'll have -2, 4, -2, 4, then -4, 2, into, we had x1, and x2 is x1 out of 2. Yes, so this is equal to 0. 0. So what do I do? I factorize out x1, so I'll have I will have x1 negative 2, 4, negative 4, 2. I have 1. I have 1 out of 2, then x1. So, but what does this mean? That means this one, x1, is twice x2, meaning I can multiply by 2 here, by 2 here, so that I have 2, 1. So x1, you just always get x1 is equal to 2, 1. In other words, this is what I have done. To remove the fraction, I have said get 1 and 1 and half, you multiply by 2, so this becomes 2. 2 by 1 and by 1 half, this becomes 1. So x1 will be 2, 1, meaning the eigenvector, hence the eigenvector for lambda equal to 5 is x1, which is 2, 1. And that is the conclusion that we can make.